Assalamualaikum warahmatullahi wabarakatuh and good day to all of you. Today we're going to learn on block diagram in relation of P&ID in chemical process control. Today's learning's outcome is to learn on how to draw block diagram in chemical process control. So what is block diagram? Block diagram is a very useful tool in process control, which is a graphical representation of transfer functions by means of block diagrams. Feedback control was the most common controller applied in industry. Feedback control was first applied by James Watt to control the speed of his steam engine about 200 years ago. It has been enhanced, improvised by extensively used until today. The term feedback derived from the fact that the control variable is measured and this measurement is fed back to reposition the steam valve. This causes the signal variation to move around the loop. This loop structure is what makes feedback control simultaneously simple and effective. When properly tuned, the feedback controller can maintain the control variable at or near the set point in the presence of any disturbance such as process flow and inlet temperature without knowledge of what the disturbance is or of its magnitude. To review the concept of feedback control, so let us again look at the heat exchanger example. Our objective is to maintain the temperature output. So this is our control variable. At desired value of set point, in the presence of variation of process flow, where there is a disturbance, and the disturbance is the temperature inlet, and the variation in the set point will be corrected by the manipulated variable known as steam in. Feedback control in this example works as follows. So a sensor transmitter measures the outlet temperature or the control variable, and then it will generate a signal proportional to it and sends it to the controller. So this is our controller. The controller will compare the set point, and the controller then calculates an output signal or manipulated variable on the basis of the error, that is the differences between the measurement and also the set point. This controller output signal is sent to the actuator of the steam control valve. This is our final control element. The valve actuator positions the valve in proportion to the controller output signal. Finally, the steam flow in and a function of the valve position determine the energy rate to the exchanger and therefore the control outlet temperature. Okay, now let's try to draw a block diagram for the temperature controller for the heat exchanger. So we know that our control variable in here is the temperature outlet of the heat exchanger. This is your control variable, and the temperature of the fluid in would be your disturbance, and your flow rate of the steam in would be your manipulated variable. So we start to draw a block diagram with the process first. Alright, so this is the block diagram for your process. Okay, so the inlet would be your manipulated variable, which is the flow rate of the steam in, and the unit of flow rate, for example, we took it as the cubic feet per hour, and the output of your process would be your process variable. Process variable in this case is your temperature, and the temperature is in degrees C. Alright, the block diagram represent here is consists of the transfer function. So we have 10 transfer function, could be in the first order, second order, or higher order transfer function. Alright, and the transfer function for your process, for example, for first order transfer function is equal to Ke power of minus St divided by tau s plus 1. Okay, so that is your plot diagram for the process. Okay, your process variable basically would be measured by the sensor transmitter. Alright, so this is the block diagram for the sensor transmitter. Okay, so the input for the sensor transmitter, okay, would be in degree C, where the sensor transmitter measured the temperature of the fluid out in degree C, and then it will send to the sensor transmitter, and the output of the sensor transmitter block diagram would be, for example, we take it as a %TO. It could be in MA, so on and so forth. Alright, so the block diagram for the transmitter, the transfer function for the transmitter would be the zero order system, is known as Km. Km is gain for the transmitter. And then the output of the sensor transmitter will send the information to the summation point. So summation point will measure the differences between the set point, between your set point, and also measured value. Alright, and the differences between the set point and also the measured value is given by the error. So this is known as the error. Okay, so the error, since the output unit of the sensor transmitter process is the %TO, so the error will be in also in %TO. Okay, and this is going to be the input input of the controller. Alright, so input the controller, and the output of the controller will be in %CO. Okay, the unit of the output controller. The transfer function for the output controller will be it can be proportional integral, and also P&Id type of controller. Okay, the transfer function, for example, we use PI controller for this temperature controlling heat exchanger. So the transfer function would be Kc 1 plus 1 over tau s. Okay, and then the output controller will send the information to the valve. So this is your valve, or the finite control element. The transfer function for the valve for first order is Kv divided by tau s plus 1. Okay, so this is basically how we draw a block diagram for the temperature controller in heat exchanger. Okay, figure shows the standard block diagram of the feedback control system. So this is the standard block diagram for the feedback control system. Okay, so it consists of this is the transfer function for the process. Okay, and then this is the transfer function of the sensor transmitter, and then it was sent to the summing point, and this is the transfer function for the set point. GC is the transfer function for the controller. It could be PPI or PID. So we'll calculate the error from the measured value and also set point, and then make a decision, and we'll send the information to the valve. So GV represent the transfer function for the valve, and then valve would then send the information to the controller process. GD in this block diagram represent the transfer function for the disturbance. Okay, remember there is a disturbance in our system. For example, in heat exchanger, our disturbance is the temperature of the fluid in. Feedback controller can have two objectives. The first one is the servo controller, is one which responds to the change in set point. So the set point may be changed as a function of time. Alright, so this is, for example, the change in set point, and therefore the control variable must follow the set point. So the process response type for the controller must follow the set point. So the equation for the servo controller is given by this equation. Km times GC GB GP divided by 1 plus GC GB GP times GM. And then the second type of the feedback controller objective is the regulatory control loop. The regulatory control loop is one which responds to a change in some input valve, and then bringing the system back to a steady state. So if there is a changes in this control variable, alright, so the process response will behave at which the system will back to the steady state. Regulatory control is by far the more common in process industries rather than the servo control loop. So the equation for the regulatory control loop is given by this equation. GD divided by 1 plus GC GV times GP times GM. GD is the transfer function for the disturbance. GC is the transfer function for the controller. GV is the transfer function of the valve. GP is the transfer function of the process, and GM is the transfer function for the sensor transmitter. For exercise, try to draw a complete block diagram for liquid level control system shown in the figure. So first, what you need to do is you need to identify what is your control variable, and then manipulated variable, and also the disturbance. For example, the control variable of this liquid level controller is the level of the tank. So this is your CV. And then your manipulated variable would be the flow rate of the Q2, stream Q2. And your disturbance would be the flow rate of the Q1. And then you need to identify the transfer function for each of the block diagram. It consists of GP. GP is the transfer function for the liquid level process, and then GM. GM is the transfer function of the sensor transmitter, and GC. GC is the transfer function of the controller, liquid level controller, and also GV. GV is the transfer function for the valve, and also transfer function for the disturbance, which is the GD. That's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh. And see you next week.